What if I told you that right now, in this very moment, Earth isn't just traveling with, our big familiar moon?
Sounds a bit like science fiction, doesn't it?
It really does.
But NASA has actually confirmed it. We're sharing our orbit with a tiny captured asteroid. Its official name is 2023 FW13.
And for now, it's basically our temporary second moon.
Exactly.
So that's precisely what we're diving into today. We want to unpack the details on this almost hidden object, 2023 FW13.
And explore how it manages to stay tethered to Earth for, well, decades.
Right, the orbital mechanics are fascinating. And maybe more importantly, what does this discovery, tell us? What other questions does it raise about what might be out there orbiting silently with us?
Well, first off, we should probably clarify for you listening. We're calling it a second moon, but the technical term scientists use is quasi-moon.
Okay, quasi-moon. Why that term?
That distinction's important. It tells you about the dynamic relationship it has with Earth. It's, let's say, part of our local system.
But it's not orbiting like the moon does.
Exactly. Its path is much more complex. It's not a simple ellipse around Earth.
Okay, let's get into the specifics then. Asteroid 2023 FW13. If it is orbiting us, even in this complex way, where is it? And how did we miss it for so long?
Well, the first thing that usually surprises people is the distance. When you think orbiting Earth, you picture something relatively close, right? Like the moon, maybe a few 100,000 miles out.
Yeah, that makes sense.
2023 FW13 is, get this, 37 million miles away.
Whoa, 37 million miles. Okay, wait.
Yeah.
If it's that far out, how can we really say it's orbiting us? I mean, isn't the sun's gravity just overwhelmingly dominant out there?
That's a really good question, a critical one.
Or we may be stretching the definition a bit just for a cool headline.
It seems like it at first, but no.
Yeah.
We have to talk about gravitational territories. Our main moon orbits at about 240,000 miles.
Right.
37 million miles is obviously much further, but it's still technically within what scientists call Earth's Hill sphere.
The Hill sphere. Okay, so that's like Earth's gravitational zone of influence.
Pretty much, yeah. It's the region where Earth's gravity is dominant enough to hold on to satellites, even against the sun's pull. So technically, it is within our gravitational reach.
But it's still mainly orbiting the sun, isn't it? That's where the quasi part comes in.
Exactly right. What makes it special, what makes it a quasi-moon, is its orbital resonance. 2023 FW13 moves in rhythm with Earth.
Like a cosmic shadow, I read somewhere.
That's a good description. It orbits the sun, yes, but its path is locked into a configuration that keeps it near the Earth-Sun system. It's not orbiting Earth directly like our moon.
So it's not circling us, it's more like dancing around us as we both go around the sun.
That's a great way to put it. It's not just floating freely, it's sort of tethered gravitationally. Specifically, it's hanging out near one of the Lagrangian points.
Ah, okay. The L points, I've heard of those.
Hmm.
Gravitational parking spots, right? Can you give us a quick refresher on what those are?
Sure. So in any two-body system, like our sun and Earth, there are 5 specific points in space. At these points, the gravitational pull from the 2 large bodies and the centrifugal force from orbiting, they all balance out.
So things can just stay there, relatively stable.
Exactly. We call them L points. 2023 FW13 is effectively captured in what's called a horseshoe, or maybe a tadpole orbit around one of these L points, which itself orbits the sun along with Earth. It circles that point, keeping pace with us.
Okay, that's the key detail then. It's not random. It's trapped in this synchronized, balanced path with our planetary system.
It really is a gravitational captive, even though, yeah, at 37 million miles, you're never going to see it with the naked eye.
And that stealth, that distance, that's why it wasn't detected for so long.
That seems to be the main reason. And it leads us right into the timeline, doesn't it? If it's locked in this cosmic dance, how long has it been going on? And crucially, when does the music stop?
Right, perfect transition. We know it's here now, but you called it temporary earlier. This relationship won't last forever.
No, it won't. The orbital models are pretty clear on this. This second silent moon will continue its synchronized orbit with us until the year 2083.
2083. So we've got it for roughly another, 6 decades or so?
About that, yes.
And then what, does the gravitational balancing act just fail?
That's basically it. After 2083, the delicate gravitational forces holding it in that quasi-moon state will break down. Its path will destabilize.
And it just drifts off?
It'll drift away, yeah. It'll become just another small asteroid wandering through the solar system. We lose our second moon, at least, this particular one.
But the timeline itself is fascinating. The fact that calculations suggest it might have been orbiting like this since the early 1900s,
Possibly even earlier.
that's what leads straight into the the scientific shock that the sources mention.
Hmm.
How could something locked into a stable, even if distant, orbit with Earth just evade detection for potentially a century?
That's really the big takeaway here, intellectually. The scientific community was genuinely, well, astonished is a good word.
Why the shock, exactly? Didn't we suspect things like this could happen?
We did, theoretically. But the shock comes from the confirmation. Finding an actual object that has stabilized in one of these distant, hidden gravitational pockets and stayed there for decades undetected. It tells astronomers, quite bluntly, that there's a significant blind spot in how we survey the space around us.
It is a bit unsettling, isn't it? You think with all our powerful telescopes and technology, we'd have mapped our cosmic front yard pretty thoroughly. But here's this companion we didn't even know about.
Absolutely. It forces a bit of a reevaluation. How complete is our catalog of near-Earth objects, really?
So why was it so hard to spot? Just too small and far away?
That's the main thing. It's small, it's dark, and it's 37 million miles out. It just doesn't reflect enough sunlight for the automated sky surveys to pick it up easily against the background stars.
But the fact that it could stay stable there for so long confirms the models, right? These L points really are effective hiding places.
They really are. And the researchers who found it asked this really powerful question, didn't they? It gets right to the core of it all.
Which was?
What else might be silently orbiting our world right now, completely unknown to us?
It's a slightly chilling thought. If one object can hide out there for a century.
It supports the belief some experts hold that 2023 FW13 probably isn't some unique anomaly.
You mean there might be more? We might not just have one temporary quasi-moon, but maybe a whole sort of secret entourage cycling through these gravitational parking spots?
It's a compelling idea based just on orbital statistics and physics. Earth is a big gravitational anchor. As countless small asteroids and bits of debris drift past us over millions of years, it's statistically likely that some get temporarily snagged into these quasi-moon orbits.
So finding 2023 FW13 isn't just finding one object. It's validating the whole physical mechanism that predicts these hidden moons could exist.
Precisely. It makes the theoretical much more real.
Okay, let's shift gears slightly. Beyond the novelty, hey, we have a secret second moon. Sure, what's the real scientific value here? So what? Why should you, listening at home, care that this asteroid is hanging around until 2083?
Right, good question. This is where its potential role as a scientific asset comes in. Some experts suggest these temporary moons, these quasi-moons, could function like incredibly valuable time capsules.
Time capsule. Okay,
Yeah.
Time capsules of what? Ancient Earth history.
Not quite Earth history, but the history of the entire solar system. Think about it. These small asteroids have likely spent billions of years drifting through deep space.
Wow.
They've been largely untouched by the intense geological processing, the weathering, the atmospheric effects that happen on larger bodies like Earth or Mars.
So they're like pristine samples, leftovers from when the planets were forming.
Exactly. They're samples of the original cosmic building blocks. When we study the composition of an object like 2023 FW13, assuming we could ever get a mission out there,
Which is a big if, I guess, at 37 million miles.
it's a challenge for sure. But if we could, we'd hope to find materials that haven't changed much since the solar system was young. Things like maybe pristine water ice or ancient organic molecules locked inside.
You mean the kind of stuff found in certain meteorites? Like carbonaceous chondrites?
Exactly that kind of material. Those are often rich in carbon, water, amino acids, the basic ingredients relevant to the origins of life.
Oh, okay, so by studying this little visitor, even from afar for now, we might unlock secrets about the raw materials that formed our planet, and maybe even life itself.
That's the hope. They are little pieces of ancient history brought into our neighborhood for a while, stabilized just long enough, potentially, for us to study them. Their makeup tells us about the conditions, temperature, pressure, chemistry way back at the solar system's birth.
Which makes its temporary status actually really valuable. It's not just whizzing by, it's a confirmed stable target. It's locked into our system until 2083. That's actually a pretty long time in terms of planning future space missions, potentially.
It is. And its discovery just highlights how fast things can change in our understanding of our own cosmic backyard. The fact it took so long to spot this one.
And that it confirms the physics of these stable captures near L points.
It really challenges the whole idea that we've got a complete inventory of everything nearby. There could be more.
Okay, so let's try and synthesize this for everyone listening. We've unpacked quite a bit. Earth, right now, has a temporary second moon. It's an asteroid, 2023 FW13.
Right. It's technically a quasi-moon, stabilized in a complex, synchronized orbit near one of those gravitational balance points, the Lagrangian points.
It's far away 37 million miles, but still within Earth's gravitational influence, the Hill sphere. And it's sticking around until about 2083.
And its relatively late discovery kind of shocked scientists. It confirms that, yeah, other hidden companions might exist, trapped silently by Earth's gravity.
And these objects aren't just curiosities. They could be invaluable time capsules holding secrets from the early solar system.
Little frozen pieces of history.
Which leads us, I think, to the final provocative thought we wanted to leave you with, something to mull over after this deep dive.
If Earth has two confirmed companions right now, our big permanent moon and this temporary quasi-moon, 2023 FW13, what happens when FW13 finally drifts away in 2083?
Does Earth just go back to being a one-moon planet? Or is there a deeper question?
The deeper question is, yeah, will another object just slot into place? Is Earth constantly sort of rotating through these temporary quasi-moons, capturing one asteroid, losing it decades or centuries later, then grabbing another one as it sails past those stable L points?
Meaning, we might rarely, if ever, actually be just a one-moon planet in the long run.
It's definitely something to think about, isn't it? What else is hiding out there in the dance?